Hello guys, welcome to AR Tutorials. Today is day 25 of solving Leetcode questions daily. Friends, today we are going to learn recursion. Recursion is the most basic and fundamental topic in the coding DSA lectures. And if you are really keen or very curious to get the optimal approaches of any hard level question, I primarily suggest you to learn recursion in depth because recursion has bare minimum time complexity and has a very vast vision of solving the hard Leetcode questions or any Leetcode questions. So if you really want to conquer the hard level type of questions or any great logical thinking questions, so recursion is the bestest approach to solve this. First of all, I want to tell you there are two types of approaches. The first approach is definitely be the iterative, and second one is the recursive. So what is an iterative? So iterative basically consists of loops. So in that we iterate our answer till we get our we iterate the loops till we get the answer. So in iterative, what it is there, we will take an element, we'll iterate it again and again until and unless what happens, we'll get our answer. If our answer is not there, our iterations would be wasted. So iterative approaches are very oftenly with big complexities. And what is recursive? In recursive, we'll repeatedly go through that condition under the circumstances until the base condition occurs. So here, what it is there, the recursion is the function calling itself inside the same function until and unless the base condition occurs is called as a recursion. Friends, this definition is basically the most crispiest definition of recursion you will ever see. Because what happens, everyone sees that function calling function. It is not recursion, friends. Function is calling function, which is itself only, but inside the function. Might look very ambiguous, but it's very easy that if I have a function, if suppose this block is a function, if this block is a function, then what happens, I'll just change the color of my pen so that you could clearly visible what it is there. Okay, so this is my function. Inside that I am calling this function repeatedly, and with some case, and if it's not completed, I'll again go it with the changed condition. I'll again call this function again until and unless this base condition occurs. When this base condition occurs, it start replacing all the gaps in between, and we'll get the perfect answer whatever we were expecting. So in recursion, what we'll do, we'll just call function repeatedly. This is there. So here I have written what is the body of the recursion. The recursion basically has the parameters. Whatever your function it is there, your parameters. So I think you must know that how the function is written, how it is called. I don't think you are such a newbie that you should you don't know this. If ever you don't know this, please let me know. There is no shame that if a concept is not new to you, and if you want to ask someone that how does it solved or what is the syntax, never feel ashamed. So newbie is not an insult. Newbie is someone who is starting as a fresher. But still, I want to tell you that these are the parameters. Parameters are the values which are passed through the function which you want to for the computation. If you want to compute something, you want that values to be computed, then you pass it as a parameters to the function. Then we have the base case. Now what does the base case means? The condition at which is the threshold. After that you can't go. If this occurs, I'll return this and compute it further. So this is the base case, and what it is, this is the function. This is the function, and this is the similar function. FUNC1. Sorry, I have forgot to written 1, but here it is 1, and here the parameters closed. Okay, so this function name is exactly similar. Parameters you can change. There is no restrictions to change the parameter, but the number and the type of parameter should be equal. So if there are two integers, then you have to pass the two integers only, but you can change the integer values. Well, whatever the computation is there, you can change it accordingly. So let's see an example. So I have told you first is the function declaration. So how we have declared the function? Int is my data type. Function int is the name of my function. Then this is the base condition. What is my base condition? If my number is less than or equal to 1, return the 1. Or what it is, if my else condition is if it is not there, n is my number into number of factorial, which is n minus 1. I hope you can see it. So what it does at every single step, you will come to know that we are performing a recursion. So now I'll solve the recursion tree. First, let's suppose my n is equal to 3. I'll take small numbers only so that you can visualize it properly. So what happens here? If n is less than or equal to 1, no. So we'll go to the return. So return what it is does, n is 3 into return of 2, because n minus 1 is 2 only. So this is first. So by so again it will call the function. So n minus 1 we have passed. So here it goes 2. 2 is less than or equal to 1? No. Then here what it is? 3. Sorry, 2 into what it is here? 1. So we have passed n minus 1. N was first 3, then it has been passed to this, and then we have 2, then we have passed 1. 1 is less than or equal to 1? Yes, of course. So this passes, it returns 1. So this is changed to 1. So this is changed to 1. So what we have to do? We have to multiply it. 2 into 1 is 2. So this value is passed to this. What is return of 2? This value is 2 into 1, 2. So this will be replaced as 2. And here we got 3 into 2. So it is 6. So my dear friends, what code it was? It was a factorial code. It was a factorial of a number. So what is factorial of a number 3? It is basically 1 into 2 into 3. It is 6. So with recursion, we have found 6. So this answer is obviously a correct answer. So what is the time complexity? Very easy. We have iterated how many times? 3 times. And what was it? We have with no extra space. So time complexity is O of n because we have traversed it. And SC is O of 1 because no extra space we have required. So friends, now I'll tell you how the merge sort is done. So quickly we will see how the merge sort we have we can do. So in merge sort, what I have done, we have taken 3, 5, 2, 1. So this was the merge sort array. So we have why recursion we use here? We'll just separate it. So till mid we have separated, then mid plus 1. So here 3, 5, then here 2, 1. So again we'll separate it 3, 5, 2, 1. So this was there. So this tree is basically a kind of a recursion. This is a recursion example. And this part, until and unless we reach here, what was this? This was the base conditions. Yes, friends, this is very easy. So we can find what was the time complexity of n log n was of merge sort. Why it was log n? Because using the recursion, we were dividing and splitting it into two parts, and that was the reason we have got an exponential decreasing term. that's why we have put an log n. And why n? Because we were decreasing it n times. So that was the basic reason of merge sort. And I think it is all clear to you that why we have used merge sort. So I hope everyone you have got this video very clear. I hope so that you have enjoyed this video and learned a lot. And I'll be posting many explanatory videos. So please stay tuned to my channel and please subscribe to it. Thank you.